All right, let's go through the last little bit. Last little bit before. So pens down, eyes up. So this gross little concoction is what we call our quadratic formula. We use it when we have messy numbers so we can't factorise using our original method. So that's one where we look for the factors of the last number, add up to make the middle. If we haven't got clean numbers, so what would be an example of that?
Negative.
Oh, we can deal with negative numbers. What can we not deal with very well though? What's that? Oh, prime numbers we can deal with, providing we've got a nice dividing words. What about decimal values? Can we deal with decimals? So if my last number was say 4.32, I couldn't identify the factors of 4.32. Make sense? So if I have fractions or decimals, it gets a little bit harder. If I have an A value, because remember that first step of our factorising was to put the brackets and the X values in and the signs in. If I can't immediately put that in because there's an A value, it makes it a bit trickier. So this will work all the time, yet I would encourage almost none of you to do it unless you have to. Why? It's confusing. What are you likely to do if you sub in this formula? Make errors. Because the formula works. I'm telling you the formula works 100% of the time. It's just we get caught in here because it's quite a complex operation. And last year I found that more students who use this incorrectly answered questions than ones who didn't. On questions where you didn't need to. There might be questions where you need to, in which case you'd have to fall back on this. Sweet? So, I've given us an example. I'll explain what it finds. So it allows us to find our x-intercepts, just like what we do when we're factorising. It's exactly the same process. We call that solving. So if I want to solve a quadratic, find where it hits the x-axis, I will use this technique or my factorising technique and null factor law. So in this case, I want you to start off by writing down your A, B and C values. So what do you think your A, B and C values are there? Five seconds. All right. Tenzin, what's your A value? Nick, B value?
X.
No. The B value is the one in front of the X.
What's that? -2.
Yep, so the coefficient in front of the X is -2. And what's our C value, right? So if we look at our equation here, what corresponds to my C value? -37, very good. You're about to see why this gets a bit messy. This is a pretty nice one. So as an example, we couldn't find a factor of 37 that was separated by 2, so we're using this. This came from my previous problem where I made a mistake. Cool? So you know I gave you the 9, it should have been 11. This is how we would solve this problem. So here I would write -2 plus or minus the square root of -2 squared minus 4 times 1 times -37 divided by 2 times 1.
Just jump in the calculator.
Yep, and that's exactly what you're going to do now. However, I would advise that we do this in steps. So I wouldn't shove it all in at once. What's -2? +2. So first one is to replace it with +2. Plus or minus the square root of, what's -2 squared? This is our first point we usually make error. It's +4. So if you put -2 squared into your calculator, for example, what do we know we get? -4. So that's like the first point where things can come unstuck. Minus 4 times -37. Now this is where I get my calculator out. I write 4 times -37 in. That's plus. 148. Divided by 2. And what does BOMDAS tell me I need to do first? What is a hidden convention here? Here's our second point of error. We need to put brackets in. There's a hidden bracket there, correct? So it's really saying what's the square root of? 152. So it's 2 plus or minus the square root of 152 divided by 2. And you would shove that into your calculator. Square root of 152 is 12.2, something like that. 12.32? 33. Okay, so I've got 2 plus or minus 12.32 divided by 2. Now, how many answers should we expect to see with a quadratic? 2 answers, correct? Have I got 2 answers here or 1? I have 2, it looks like 1 though, correct? Because I have to deal with both the plus and the minus. So what I'm really saying here is x equals that, or x equals 2 minus 12.32 divided by 2. And I'd shove those into my calculator. I would get 7.16, I think, or 5.16, negative 5.16. Am I right or am I wrong? I'm just doing that in my head. Is that right or wrong? Oh, you pick my time. Cool. When do I do the divide? When do I get rid of the divide? At the end. I have to add the tops first, then divide them. Does that make sense? That's another point. So there's 3 points where kids tend to come unstuck. The negative negatives, the squaring their negative number, oh, it's 4 points. Not applying their brackets and then dividing too early. Sweet. So if you're going to use this technique, what do you really need to be strong with? Bomb dash. You didn't know your bomb dash. And you need to know what your calculator thinks. What does your calculator follow? It follows bomb dash religiously. It doesn't know about things like our little convention where if we've got a long bracket, you put a long root, you put the brackets in there. We know that, but it doesn't know that. So you need to be really careful when you're applying this formula in your calculator. So what does it find? It finds my x values for my intercepts, just like when I'm factorising it. When should I use it? When I can't factorise normally, so when I can't identify a common factor that I can add or subtract to get my b value, or when I have a coefficient that I can't deal with. Sweet. There is ways you can deal with small integer coefficients, but if in doubt, you can use that technique. Sweet. Would I expect you to recall this in year 10 off the top of your head? No. Although I don't think it's presented on the senior formula sheet, just FYI. But you don't need to know it for year 10. Sweet. If you need it, it'll be given. Awesome. Okay, you guys can. What we'll do is we'll give you another one to practice, hey? Give you another one to practice. Give me some weird numbers. Yep. I'll go 2x squared minus 4x minus 68. Oh, not 68, it's too big. 14, yep, I'll put that up. Let's go, see if we can get that one done using the quadratic formula.